Hello. This is a second rather recent study, just to show as an example for what has been done using ISIMIP data, and compared to the previous paper that Stefan presented, this is more of a model evaluation. So yeah, a study that looks at historical events and simulations. And the question was here really, how well can we model the overall impacts of an extreme event? And this was published in Nature Communications last year. And like Stefan's paper, this was a big collaboration between many people from different sectors in ISIMIP. So also, yeah, really nice collaborative work. So the motivation here was that if we want to know how costly or unhealthy or overall just how bad a given level of global warming is going to be, first we need to aggregate impacts in a large number of different sectors or systems, like agriculture, industry, health, biodiversity, and so on. Secondly, and crucially, we have to include the impacts of extreme climatic events, because those events really cause large damages, as we already saw in Katja's presentations, compared to just if you were just to look at average changes in average climates, you would miss out on a lot of the damage. Now, previous cross-sectoral impact estimates largely ignored these impacts of extreme events. And the process-based global impact models that take part in ISIMIP, if they are applied in this way consistently across sectors, would be the ideal tools to do this, to estimate the impacts of future climate extremes in the different sectors. But can they do that? Are they fit for the purpose? That was a bit the question here. And how we addressed it was picking a specific historical event for which we have decent data about the actual impacts, and which is also a good analog for similar events in the future. And so we selected the 2003 heat wave and drought in Europe. And then we ran the models with meteorological inputs from climate reanalyses, so really observational inputs, not climate model forcing. This was done in the ISIMIP 2A simulation round. So as Katja explained, this A part of the simulation round is where we run the models with reanalysis or observations-based climate data. And then in the B part that Stefan was making use of, models are run with climate model output. And then we assessed how well the models in each sector are able to reproduce the observed impacts. And we again used a common metric across sectors so that we could synthesize the results in the end. And for 3 of the sectors, we had a quite large number of models taking part. So really we could look at a whole ensemble of models. And then there were 2 other, there was one model for hydropower and one statistical model for heat-related mortality, which we also used to cover those sectors. What was this event like? As many of you might remember, this was a really long, hot and dry summer across Western and Central Europe. You can see the temperature and precipitation anomalies here over space and over time. And this caused large excess human mortality, especially in Southern and Western Europe. There were tens of thousands of additional deaths due to heat, as this event really pushed the health system in some of these countries or cities beyond their capacities. But there were also really large impacts on crop yields, so really large shortfalls in crop yields, very low river flows in many important rivers, which impeded then navigation and also therefore impacted trade and industry. Energy generation was impacted, both thermal and hydropower energy production. And also there was a large negative anomaly in ecosystem productivity. So these are just some of the major impacts that are well documented in the literature. And of course, seen from a 2003 perspective, this was a very exceptional event. But given climate change, it will not remain an exception. So the summer temperatures of 2003 will soon become the normal summer temperatures in Europe because of climate change. And of course, since 2003, we've already had a couple of really hot summers. So I'm just showing a few exemplary results here. I don't have time to go through the whole paper, of course, but just looking at first at the ecosystem productivity. So this is gross primary productivity, and you see the anomaly in blue on the left-hand side, and on the right-hand side is the model ensemble, and we looked at the anomaly compared to the historical average in terms of standard deviations. So according to observations, this anomaly was 4 to 5 standard deviations below normal gross primary productivity, depending a bit on the region that you look at. And what we see is that some models, so the models are the little numbers here, some models come quite close to reproducing this magnitude of the anomaly, but other models don't. And some models actually simulate a quite large positive anomaly, interestingly. So if you look at the model ensemble as a whole, and the green boxes here give the interquartile range, then you see that you know, it really depends on the model choice whether you somehow get close to this real observed anomaly at all, or whether you know, if you pick one of these models here, you might get a totally false impression, let's say, of the impact of this heat wave on ecosystems. Human mortality here again, now the black symbols, circles and diamonds, are reported numbers for excess mortality per 100,000 in different cities, and then the gray bars represent different variations of the statistical model. And here again, you see that for some cities like Barcelona or Rome, the model comes fairly close to the reported excess mortality numbers. But then for other cities like Milan, Paris, Turin, the excess mortality is being strongly underestimated. And so we did this for all these different sectors and all the places in Europe that we had data for that showed a strong anomaly due to the heat wave. And in summary, we saw that the models do match the magnitude of the observed anomaly in some sectors and places. For instance, river low flows are reproduced quite well in general. Also, crop failures in Eastern Europe are reproduced well by the crop models, but not in others. So as we saw, excess mortality in Italy and France, the crop failures in Southern Europe, the GPP reduction are strongly underestimated by the model ensembles. That means that if we had tried to predict the overall impacts of the 2003 event with our current models, we would likely have underestimated the total damages. So it's worth trying to improve the representation of extreme event impacts, because after all, these process-based impact models form a really important basis, as Katja already alluded to, for assessing any downstream effects, such as economic damages or health burden from climate change. That's it.